Hello everyone, I'm Lisa Wang, a PhD candidate at Colorado State University and working with Professor Joe Van Lint. Today I will introduce the chaining of physical infrastructure damage model and dynamic CGE model through capital shocks. First, I will introduce the CGE model generally. So the computable general equilibrium model, the CGE model, is a data-driven model that can simulate the flow of results among the entities, including households, firms, and the local government. And the model can predict the dynamic economic change in domestic supply, employment, and total household income. And the social accounting matrix is the most important matrix for the CGE model. And the matrix organizes the data, can model the interaction among the entities, and can represent the flow of results in economy at a point in time. So the CGE model can be solved based on the equilibrium of the social accounting matrix as well as a series of mathematical equations. As you can see, the figure at the left-hand side is a simplified Joplin social accounting matrix example. So as you can see, the social accounting matrix, actually it has some sub-matrix inside. And for different sub-matrix, it has different data cells. For example, the input-output matrix was derived from the US Bureau of Economic Analysis data, and the household consumption matrix was determined from the POPs data and the American Community Survey data, ACS data. And both the capital stock values and the building to sector mapping can be determined by county or sensor data. And some users might even want to buy the atom data as well. So I think maybe not all of the audience today were from the civil engineering related major, so I will still briefly introduce our framework to integrate our physical model and economic model. So first, we will have the building data and economic data. And for building data, we have building archetypes, construction year, footprint area, etc. And we can use the building archetype information and fragility model to assign the fragility to each building. And then we can develop a hazard model. For example, we can develop an idealized tornado model and determine the building damage throughout the community. And after applying the Monte Carlo simulation model, MCS model, we can determine the building building functionality probability for each building. And as I mentioned, we also have a lot of economic data to develop the social accounting matrix. One of them is the capital stock values, and we use both building functionality probability and the capital stock values to determine our external capital shocks by sectors. And then we can use these external capital shocks to apply to the CGE model and to break the old equilibrium of the social accounting matrix. And after calculating and building a new equilibrium of the social accounting matrix, and we can solve the CGE model and determine the dynamic economic change in resilience matrix. And for this presentation, I will mostly introduce the linking part. So that means the right part as you see in the framework. For next slide, I will mostly introduce a capital shock notebook. So this is the capital shock notebook, and I will rewrite it, and I will come back to it shortly. So our in-core has released a module called a capital shock. So there are 3 required input of this module. So they are building inventory data side, building to sector mapping data side, and building functionality probability data side. And the output of this module is capital shock by sectors. And you may want to ask, how many sectors do you have and what are sectors? And also I saw the short shows, but for the Joplin test bed, we have 6 sectors in total, and 3 residential sectors and 3 non-residential sectors. And the residential sectors, they are housing surveys HS 1 to 3. And the difference are the price of the buildings, or we see the appraisal values of building. For example, HS1 is lower value homes, HS2 is higher value home, and HS3 is rented residential buildings. And for the non-residential sectors, they are goods, trade, other. And goods are large manufacturing industries, trade is retail, and other is a combination of other services such as the hospital, school, churches, etc. And all of these 3 non-residential sectors are aggregations of the next sectors. Let's go back to see the notebook result. For example, list the building inventory data side. For each building, we have architect information, parcel ID, and the construction year, footprint areas, and some other information, include the appraisal value of the building. So this column is very important to create a capital shock. And for the building to sectors, for each building, and it will be assigned to a specified sector. For example, it has 1 to 3. And the list the functionality probability data side actually is the output of our Monte Carlo simulation module. And for each building, we have the limit state and damage state, which determined from the building damage module, and then we can determine the failure probability column. So it's the 0, that means this building is fully functional. That means this building may be located outside of the tornado hazard. And finally, the output of this capital shock value will be something like that. For each sector, we will have a shock value. So shock value is a kind of value between 0 to 1. So for example, for the first row, that means for this sector of HS1, there are around 63.4% capital stock remain after tornado hazard. So let's go back to the slide. And the final slide, I will mostly introduce the algorithm. So actually for this module, the algorithm is relatively simple. So first we need to filter the data. So we cannot have a data set which is perfect. So more or less it will have some data missing. So actually the Joplin testbed is well organized, but still has the amount of data was missing. So we need to remove the around 5% of the data. Some of the buildings doesn't have the capital value, and some of the buildings doesn't have the mapping data. And then we merge the 3 data sets by GUID. And then we can use this equation to determine the sector shocks as a percentage of capital stock remaining to determine our output of the capital shock module. And that's my part. It's a short presentation, and thank you very much. I'm happy to have any discussion with you guys.